sigma x bar minus y bar is equal to the square root of sigma x squared over nx plus sigma y squared over ny. So that's the part that will go in this denominator right here. Here. Sigma x squared over nx plus sigma y squared over ny. So I have a formula for the test statistic now. And the reason why I made a big deal about this is because this is going to be the one that I change each time when something changes. But this is my base. This I better know. I better know that formula deep down. So let me get back to my example right here and finish it up. So Z naught, the test statistic, is now x bar minus y bar, using that formula that I just created, minus mu x minus mu y from the null, divided by radical sigma x squared over nx plus sigma y squared over ny. It's the same formula I just created. And I just want to finish up this problem. So equal to x bar 689 minus y bar 694 minus 0, because in the null hypothesis this number is 0. It doesn't have to be 0. I could say, let me check to see if the difference in means between women and men is 50 points. In that case, this number would have been 50. Divided by radical sigma x squared is 3 squared over nx is 50 plus sigma y squared is 2 squared over ny, which is 80. And then I finish up this problem. Let's see. Let's do it. So let's do the bottom first. I have 9 over 50 plus 4 over 80. 9 over 50. Oops, I should have put it in brackets. Let's do that. 9 over 50 plus 4 over 80. Square root of that. And then the top is 689 minus 694. So that's just a negative 5. Negative 5 divided by answer. Negative 10.426. Did you get that? Yes? Negative 10.426. That's negative 10.43. Let's go and drop it into this picture. I also need critical values here. So I go to my t-table and I go to the last row and look up 0.05 in one tail. It's Z, so I go to the last row, 1.645 and minus 1.645. And I go and I drop this, minus 10.43. So it's here, minus 10.43. Z naught. So conclusion, reject H naught in favor of HA. Oops. And furthermore, Z naught lies in the left rejection region. So conclude that mu for females is less than that for males. You wouldn't think so when you first look at the data, right? Look at the data. 689 versus 694. It seems like pretty much the same, right? So if you had to guess this, you would say, I don't think there's going to be much of a difference between male and female scores. But this is saying that the difference is significant at this level. So it's saying conclude that mu females is less than mu males. Basically, we're saying mu females minus mu males less than 0, where females is X and males is Y. Get what I'm saying? Let's put this in our calculator. Stat test two sample z-test. Two sample z-test. Input data or stats? Stats. Sigma 1 equals 3. Sigma 2 equals 2. X bar equals 689. N1 equals 50. X2 bar equals 694. N2 equals 80. What side is your test? It's a two-sided test, so I pick the first option and I go to calculate. Minus 10.43 is my test statistic. P-value is really, really small, so P less than alpha, reject H naught. Get it? So let me write that in red. Stat, test, calculator. Stat, test, two sample Z test. Data or stats? Stats. The rest is doable. Get it? Okay, to be continued on Wednesday.
Thank you.